Welcome to this session where we are going to discuss the computer graphics programming. Now, how to write computer graphics program? What are the changes we have to made in C so that the computer graphics program can run? And we will write few programs. So that is nothing but agenda of today's session. Session number 1. Now, first of all, while writing a program or you can say graphics program, we are going to use C programming language, where in normal programming, whenever we are write any C program, at that time we are writing the header files, then void main. Inside the main we are writing the some statements and functions like this. So that is nothing but in general structure of the C program. But in case of graphics programming, the structure will be same, but you have to do some additions. So you have to inculcate few additions. So those additions are, first addition is you have to add header file for graphics function. The header file is hash include graphics.h. So you must include graphics.h as a header file while writing the graphics programming. So that is the first change from the normal programming in C language. Then second change is, or second difference or second addition is, you have to declare two variables, that is GD and GM. You can give any name to that. You can have G or M like this also, but you have to declare two variables, that may be GD and GM, and then call init graph function. So this is nothing but integer GD is equal to detect and GM, and init graph ampersand GD ampersand GM and path of the BGA file. So this is required for initializing the graphics mode. So you have to initialize the graphics mode by writing those two functions, those two lines. Then third one is, we are dealing with the pixels. So in case of graphics programming, we are plotting the pixels. So to plot the pixel, you have to use putPixel function from the graphics.h. So the putPixel function is putPixel x comma y comma color. So this is the syntax of putPixel function. Now I will show you how that graphics program can be written. Okay, see here, suppose this is the okay. So here I want to write some simple program to display the pixel. First of all, I am writing hash include stdio.h, hash include conio.h, hash include graphics.h. So this particular file graphics.h, it contains various graphics functions. Then you can write void main, then write down integer GD is equal to detect and GM, then call the init graph function ampersand GD ampersand GM, and this is the path of BGA file. This is the path C colon double slash turbo C3 then BGA. So this is the BGA, or you can say the path you must provide. If you are unable to provide this path, then your program or graphics program won't work. Now I have used a simple function, that is put pixel 10, 23 and 3 is color. If suppose I am changing color to 5. Now you can compile this by Alt F9, compile it, then use Control F9 for running it. Now here you are not getting the output, so go for Alt F5. So here you can see the output, but I think this pixel is so small that you can't see it. This is the pixel. This is the pixel you can see, which is displayed at the location 10, 23, 5. There are other functions. In general function, there is a line function like 10, suppose 20 comma 45 comma 45. I'm using this line function, which is inbuilt function written inside the graphics.h. I will compile it and I will run it. Then you can find the line. So this is the line. You are getting the line. You are getting the line. But if you are unable to include, or if you are not including the graphics.h, then those functions like put pixel or line will give you some error. Okay, so those are some changes, or those are some additions you must do in each and every graphics program. You must do that into each and every graphics program. Now we'll begin with the actual agenda of the graphics programming. Now after that, after addition, you must see those or you must write it somewhere that what must be added. First, you have to add the header file for the graphic function. That is nothing but hash include graphics.h. Then declare two variables gd and gm. The name can be anything. Gd is equal to detect and gm, and call that inside the init graph function you have to call, and provide the full path of bgi file. Then use put pixel function for plotting the pixel on computer screen. So this is simple function I am telling from the graphics.h. Now there are various experiments we have in the in this. So list of experiment. First, you have to implement DDA line drawing algorithm. Another, it is implementation of Bresenham's line drawing algorithm. Then third is implementation of midpoint circle drawing algorithm. Then implementation of area filling algorithm. That is nothing but we will write for boundary fill. There is one more program, that is implementation of scanline polygon fill algorithm. Then implementation of Bezier curve. Then character generation by using bitmap method or stroke method. Then implementation of 2D transformation like translation, scaling, rotation, reflection, shear. Then implementation of line clipping algorithm like Liang-Basky algorithm, and program to perform animation. So we can write program for performing animation. Now we'll begin with the first, that is DDA line drawing algorithm. It is already discussed with you, and those are the steps of DDA line drawing algorithm, and by using that steps we can write the program. So what are the steps of DDA line drawing algorithm? Step number one is you have to accept input x1 y1 and x2 y2 as the endpoints of the line. So you must accept the input. For that line, you can use printf and scanf function so that it will accept x1 y1 x2 y2 from the keyboard. After that, you have to calculate dx is equal to x2 minus x1. That is the difference between x coordinate, and dy is equal to y2 minus y1. That is nothing but difference between y coordinate. Then it is if and else statement. If absolute dx is greater than or equal to absolute dy, length will be dx, else length is equal to dy. Then calculate x increment. This is the increment factor, dx upon length. If suppose absolute dx is greater than dy, then length will be dx. So in that case, x increment will become dx upon dx, that is nothing but 1, and y increment will be dy upon dx. Then you can plot the first point, that is x1 y1. Then calculate x of k plus 1 is equal to x of k plus x increment. So you have to calculate the recursive points, that is x of k plus 1 is equal to x of k plus x increment. Whatever answer you will get, that will become x of k again. So this process or this step you must repeat, and y of k plus 1 is equal to y of k plus y increment, and then plot x of k plus 1 y of k plus 1, and you have to repeat this step number 6 how many times? Length times, means length means maybe dx or dy times. So that many times you have to repeat it, and finally you have to stop it. So this is nothing but the DDA line drawing algorithm. So we'll write the algorithm, we'll write the program for it. So see here how that program can be written. First, hash include stdio.h, conio.h, graphics.h, void main, integer gd, detect gm, and init graph. Now I'll write, I want how many variables? I will take it as a float, x1, comma y1, comma x2, comma y2. Those are the input, or you can say inputs, x1 y1 and x2 y2. Then we want dx, then we want dy, and then we want x increment, comma y increment. So that many variables we want. Then init graphs, embassy gd gm, and this is the path of bgi folder. Bgi folder, remove it. After having those, first of all, you have to accept the inputs from keyboard. You have to accept the inputs from keyboard. So I will write printf enter x1. Suppose enter x1. Then I will write scanf x1, comma x1. Then I will write printf and scanf for x1 x2. So I will copy it. It is nothing but enter x2. This is x2, and we can keep it as y1. So this is nothing but we have used printf and scanf for taking the input. Now input is we will have x1, y1, x2, and y2. That is nothing but endpoints of the line. After having the input, what you have to calculate? You have to calculate dx. Dx is equal to what? X2 minus x1. X2 minus x1. And what about dy? Dy is equal to y2 minus y1. Okay. So dx and dy, we have written dx is equal to x2 minus x1, dy is equal to y2 minus y1. Now write down the if and else statement for calculation of length. So if absolute dx greater than or equal to absolute dy, then what it will do? Length is equal to dx, else length is equal to dy. Okay. So if and else length dx and dy. Okay. Now see here absolute function abs. This is absolute function. Absolute use of the absolute function is if suppose absolute of minus 10, answer will be 10. So it calculates the magnitude of the value. It is not going with the sign. And absolute function, it is include, included in mat.h. Mat.h. So you must include that particular header file. Okay. Then here we will get length dx and dy. After having the length, find out the two values, that is x increment is equal to dx upon length, length, and y increment is equal to dy divided by length, length. Okay. So we have found out x increment, y increment. We are going with the algorithm. So this algorithm, we have calculated absolute dx dy, length dx dy, then we have calculated x increment dx upon length and dy upon length as y increment. Now what you have to do, you have to put the or plot the first pixel, and after that we have to calculate the recursive calculation of x of k plus 1, x of k plus x increment, like this. Now after finding length, what you have to do, you have to use for loop. So you can use for loop for I is equal to 0, I less than, up to what you have to perform this for loop, till length. I starting from 0 till length, then I plus plus. Now inside the for loop, it will have the x and y values, so that you can write it as x1 is equal to x1 plus x increment, and then y1 is equal to y1 plus y increment, and then write down the put pixel function. Put pixel x1 comma y1 comma, you can provide the color. Suppose I am providing the color as a 5. So this for loop will be implemented, or it will be repeated how many times? Length times. It is beginning from 0 till less than length. It is recursively added. X1 is equal to x1 plus x increment, y1 is equal to y1 plus y increment, and put pixel x1 y1 comma 5. Now we'll see what are the issues we will have. Compile, there are errors. Length, so we have not defined the length. So you can have this length. Compile it again. Error. Okay, so you can have this as comma I. Okay, x1 floating point formats not linked. Okay, we'll have this. To compile it, run it. Now enter x1, that is suppose 100. Y1 is 120. X2 is 300. Y2 is 350. This is the line we are getting from 100, 120 till 300 and 350. So we have drawn this line by using DDA line drawing algorithm. You can compile this program once again with different values. Suppose x1 is 10, y1 is 10, x2 is 50, and y2 is 100. So you will have this value, or you will have this line from 10, 10 to 50, 100. Now this programming is very simple. You have to follow the algorithm stepwise as we have followed here. First of all, this is nothing but what is the this one is input. We are taking input. After that, second stage is you have to calculate dx and dy. Calculate dx and dy. Okay. After calculation, next is if else statement. If else for calculation of length. Then after calculation of length, you will have x increment and y increment value. So here we have calculated x increment and y increment. Then after that, we are recursively calculating the values till the length. So recursively calculating the value of x and y till it reaches to length, or I reaches to length. So this is nothing but how we can write the DDA line drawing algorithm. It is simple. You have to just follow the steps, whatever we have. So those are the steps. You can compare those steps with the program. You will find there is a similarity. Only thing is you must apply somewhere logic, when to use for loop, when to use if else loop, when to use uh, other loops, do while loop, etc. And based on that, you can write the program. So this for loop is for repetition, or repeat step number 6 length times. So that hence we have used this for loop, because this step number 6 must be repeated how many times? It must be repeated length times. So that I have written the for loop. So I think you have understood how this program is written for DDA line drawing algorithm. It is very simple. Repeating length times. Okay. So this is about DDA line drawing algorithm. You can write the get ch function, so that the output you will have x1 is 23, 34, 56, 123. So this is nothing but what we got the line from 23, 34, 56, 123. So this is nothing but DDA line drawing algorithm. So you can practice this algorithm at your home, and you can write the program in some different way, or by using the same way you can use this for writing the program. Now we'll move towards next algorithm. That is nothing but Bresenham's line drawing algorithm. So we have written for DDA algorithm. We will move towards the Bresenham's line drawing algorithm. Now that algorithm is with you. Those are the steps of Bresenham's line drawing algorithm. First step is you have to accept line endpoints, that is x1, y1, x2, y2 as the input. After having that endpoints as the input, calculate delta x as x2 minus x1, and delta y is y2 minus y1. Similarly, you have to calculate other parameters, that is nothing but 2 delta x minus, or 2 delta x and 2 delta y. In third step, calculate initial decision parameter. P0 is equal to 2 delta y minus delta x. Now step number 4 is if p of k less than 0, then x1 is equal to x1 plus 1, means x is incremented by 1, y will remain as it is, and the next decision parameter is previous decision parameter plus 2 delta y. In other case or else part, x is incremented by 1, y is also incremented by 1, and the p of k plus 1, that is nothing but decision parameter, it is equal to p of k previous decision parameter plus 2 delta minus 2 delta x, and this will be repeated how many times? Delta x times. So this algorithm is for slope less than 1. Slope less than 1 means the line is more longer in x direction than the y direction. So this, you can modify this algorithm for slope greater than 1, but while writing the program, now we can use this algorithm which is derived for slope less than 1. Now you will have that particular steps, so you can have in front of you. We will use those steps for writing the program. So I will show you how to write the Bresenham's line drawing algorithm program by using this algorithm. This is a program for Bresenham's line drawing algorithm. We'll write it from the scratch. First of all, write down the header files in studio.io.h, conio.h, then graphics.h, then void main, define integer gd is equal to detect gm, then in case of Bresenham's algorithm, all the calculations are integer in nature, so that we will write integer x1, y1, x2, y2, dx and dy, dx and dy. Then we have written the init graph function. Those functions must be included, means those lines must be included in all the programs, computer graphics program. That is nothing but integer gd is equal to detect gm and init graph. So you must write everywhere in each of the program. Then and then only your program will be executed in the graphics, or it will display the graphics. So init graph ampersand gd gm c colon double forward slash turbo c3 then bgi. So this is the path of bgi folder. You must call that function for initializing the graphics. Then accept the inputs from the keyboard, that is by using printf scanf function x1 y1 x2 y2. Now, after accepting the inputs, what you have to do? Calculate dx. Dx means it is difference between x2 minus x1, and dy is y2 minus y1. Now, as per the algorithm, what are the other steps? You have to calculate initial decision parameter. So I will write p. So you must define that p here. That is nothing but declaration of variable. P is equal to. So whenever you will see the algorithm, p is equal to 2 delta minus delta x. 2 delta minus delta x. You can write 2 into dx or dy minus dx. So this is the initial decision parameter, that is a p is equal to 2 dy into or minus dx, initial decision parameter. After writing or after calculating initial decision parameter, based on that parameter, you will have x will be incremented or not, means if and else statement. If and else. You can write it if if what p is less than 0, then what you have to do, x1 is equal to x1 plus 1 colon y1 is equal to y1 and p is equal to p plus 2 into dy, okay? 2 into dy, else. So you can see the algorithm here. After calculating initial decision parameter, that is p0, we have calculated here as a p. We have written as a p 2 into dy minus dx. Then go for if p less than 0. So instead of p of k, generalize the p because it is recursively added or recursively calculated, so that there is a confusion if you use p of k plus 1 p of k. So instead of that, write down 1 p, the p is equal to p plus whatever it is, so that it is better to understand the program. Then in else part you can have x1 is equal to x1 plus 1, then y1 is also incremented by 1, y1 plus 1, and finally p is equal to p plus 2 delta y 2 dy minus 2 into dx. So if and else part is over, but remember those particular if and else part are that part you must repeat it how many times? Delta x times. Means you must use somewhere for loop. So you can use for loop here. So for I is equal to 0, I less than dx, I plus plus, so that this part if and else will be repeated how many times? Dx times, dx times. Then here you can write put pixel function to display the pixel, that is nothing but x1 comma y1 comma color you can choose 6. Now see here, as per our algorithm, as the step number 4 is p of k less than 0, so we have written if part, this is the if statement, this is the else statement, and those if and else must be repeated how many times? Delta x times, means dx times. So we have used for loop for I is equal to 0, I less than dx, I plus plus. Whenever you will get any value of x or y, suppose p less than 0 means x1 y1 you will get, so that will be displayed by using put pixel. Then this function will come again, or this for loop will start from first, if suppose it is ended in else, then you will get x1 y1, that will be displayed by using put pixel function. Means any value from if or else, whatever you are getting as x1 or y1, that will be displayed in each iteration and till end. Once it is dx, the final line will be drawn, okay? So that is nothing but put pixel x1 y1, the p value we must write. Okay, we have defined whether p, yes, we have to define I is already defined, is declared dx dy else. Okay, now we'll compile this, we'll save it. For compilation you can use shortcut key as alt F9, and for running it you can use control F9. Okay, then check whether the output you are getting scanf floating point is not linked. We have defined integer, so it must be d. So compile once again, it will ask for x1, suppose 12, x1 is suppose 12, y1 is 12, x2 is 160, y2 is 56. See this. This is the line by using Bresenham's line drawing algorithm. This is the line by using Bresenham's line drawing algorithm. I will show you how that line will be drawn pixel wise. So I will use one function to show you how it actually draws the line. Include dos.h, and I will write delay into for loop. Delay 100. Now here you can see how the line will be drawn pixel wise. Suppose it is 12, 12, 200, and it is suppose 150. Now see here how the line is drawn, one pixel at a time. Based on the calculation, based on the for loop, it will draw the line from 12, 12 to 200, 150. And once it reaches to 200, 150, it will stop. Okay. So this is nothing but the second algorithm of line drawing algorithm, that is Bresenham's line drawing algorithm, and we have written the code for it. It is very simple to write. You must know the algorithm, and based on the steps from the algorithm, write down the functions or write down the loops, and you can execute it, and it will draw the line as per the algorithm. So here we have seen DDA line drawing algorithm and Bresenham's algorithm. So I think you have understood how that program is written by accepting the lines from keyboard, then calculating the various things using the for loop, using if else statement, and using put pixel function. See the put pixel function. You can click on this. This is the put pixel function from graphics.h. So those many functions are in the graphics.h. Okay, so this is algorithm Bresenham line drawing algorithm. So we have completed two programs, one for DDA algorithm, one for Bresenham's line drawing algorithm. And by using the steps of DDA and Bresenham's, we have written the code in C language, and it is very simple. As per the steps, you have to write the code in the C language. Only change difference is you must include few lines, that is nothing but inclusion of graphics.h, then declaration of variables gd and gm, and then init graph function calling, and finally by using put pixel function you can write the graphics program. So those are the list of experiment. This is list of experiment DDA Bresenham. Now in next session we will write midpoint circle drawing algorithm, program for midpoint circle drawing algorithm, and we will implement area filling algorithm, that is nothing but boundary fill, in session 2. We will stop here. We will again join at 3:50.